that we looked at yesterday, they were something to a power, so we brought down the power, inside stays the same, and then times the derivative of that inside piece. This one isn't a calculation question, it's more of an interpretation. Remember, a derivative gives us the slope of a tangent line, where it's a rate of change. So we need to be able to understand when we're doing derivatives what those things represent. We have an oil refinery that makes U liters of gasoline from X barrels of crude oil. Then they make Y grams of petrochemical from the U liters of gasoline. Okay, so they take crude oil, make gasoline, take the gasoline, make petrochemical. Okay, there's a series of events. So I just want to know, what would the units of these things be? dy du means the derivative of y in terms of u. We know a derivative is just slope of a tangent line. Okay, you did rate of change problems back in Algebra 1, and we know it's basically the unit of the top per unit of the bottom. So when I look at this, y is grams, so this would be grams per, u was
liters.
So it's grams per liter. So what would du dx represent? U is
Liters.
per,
Barrel.
x is barrel. And dy dx. So y is
grams per.
So we'll do a lot more applications with these types of problems, and putting units on things later on, probably after Christmas. But just kind of touching on now, getting used to what those units might look like. All right, you guys try this next problem. Based off what we did yesterday, see if you can get the derivative of this for me. All right, so 100 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside is 3x squared. So you got 300x squared times x cubed minus 1 to the 99th. Next one, same type of thing. As through that negative exponent in there, we've tended to have a few more problems with those. So the negative 3 comes down, inside stays the same. When you subtract 1 from the power, it becomes negative 4 times derivative of the inside. We could leave it like this. We could choose to multiply a few things together. If you wanted, you could distribute the negative 3 through the 10x minus 2 and make it negative 30x plus 6. But it doesn't matter, both answers are correct. Can I distribute the negative 4 through this parenthesis? No, because it has an exponent. Order of operations, you have to do exponents before you multiply. So the only reason I can multiply these two together is because there's no exponent out here. All right. Can we go to a more challenging one? Right, let me just ask the question. What would I have to do here? We have two options. We can do quotient rule, or we could bring this up to the top and make it a negative 2. Before yesterday, we had to do quotient rule because we didn't know how to do the derivative of this. Now that we have the chain rule, that would be an option. A lot of times that would be faster than quotient rule, but you could certainly do either one. So then we get negative 2 times 2x cubed minus x plus 7 to the negative 3 And then derivative of the inside is 6x squared minus 1. If you did quotient rule, your answer isn't going to look quite like this, but algebraically they are equivalent. Like this -3 would move that down to the bottom. So if you did quotient rule, you would have -12x squared plus 2 over 2x cubed minus x plus 7 to the third. So you get the same thing, just written a little bit differently. Okay, now let's do, the next 3 are a little more challenging. So we're going to take a look at these and then see where we're at time-wise. If I asked you to do the derivative of this, what would we have to do?
You'd have to put the 5 in front of it and then do quotient rule inside for the derivative part.
So the 5 comes down, inside stays the same, subtract 1 from the power, so it's now to the 4th, times derivative of the inside. So for the derivative of the inside, we have to do quotient rule. So quotient rule is low d high minus high d low over low squared. Is everybody with me here? Let's clean this up. When I have z minus 1 over z plus 1 to the 4th, I could write this as z minus 1 to the 4th over z plus 1 to the 4th. Okay, here if we multiply, we get z plus 1. I have to distribute this negative, so minus z plus 1 over z plus 1 squared. So my z's cancel here. 1 plus 1 is 2. If I'm multiplying, could I go ahead and take my 5 times my 2? So on the top we have a 10 times z minus 1 to the 4th. On the bottom, z plus 1 to the 4th times z plus 1 squared becomes z plus 1 to the 6th. So chain rule isn't just a standalone thing. We may use it in combination with product and quotient rules. Is that okay? Another one. What am I going to have to do here? Yeah. Product rule. The big thing, we have those parentheses multiplied. So if I start doing my product rule, so product rule starts out derivative of the first. Here is my first thing. If I want to do the derivative of that, what do we have to do? Chain rule. So the exponent comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, which is okay. The product rule is derivative of the first times the second one plus the first derivative of the second. here's the second one. You have to do the chain rule to do its derivative. So the 2 comes down, inside stays the same. Subtract 1 from the power, so now it's just to the first, times derivative of the inside, which is 3x. Okay. We are really to the point where there are lots of different stages you might leave your answers in. I'm going to have just a few generic expectations with these. You know, the 2 and the 3x, couldn't we go ahead and multiply those? Yes. I would like for you to pull coefficients to the front of the terms. Do any obvious multiplication. You know, over here, if you would like, you could multiply the 5 and the 1 plus 2x, but that's not necessarily a requirement for you. So you have some different options with how far you go on this. So let's at the very least, I'll go ahead and multiply the 5 and the 1 plus 2x. So that would give me 5 plus 10x, and x plus x squared to the 4th, 1 plus x cubed squared. And this one I'm going to multiply the 2 and the 3x and bring that in front, so that's 6x squared times x plus x cubed squared to the 5th times 1 plus x cubed. Could I multiply more? Yes. Could we factor things out? Yes. I'm just not going to require you to go to that length right now. Okay, we're just focusing on the derivatives. So I'm not expecting you to spend a huge amount of time simplifying your answers, just the basics. You know, if you have a 2 times 3, go ahead and make that a 6, but you don't have to factor or anything like that. Is that one okay? Let's try this one.
Just tell me I have to have some seconds.
I have not updated my board. Okay, so quotient rule. So low D high. How am I going to do the derivative of the top? Change. So 3 comes down. 1 minus x squared. The second derivative of the inside is -2x minus high d low. So derivative of the bottom. So 2 comes down. Inside stays the same. Subtract 1 from the power. Times derivative of the inside would be 5 plus 12x. Over low squared. Okay, this one's pretty ugly. What are the obvious simplifications? What would I want you to do at least? We could, at the very least, could I multiply my 3 and my -2x and bring that out to the front of that term? In this one, you could distribute your 2 through the 5 plus 12x. That's optional, but at the very least, I would appreciate you bringing the 2 to the front of that term. So this would give me negative 6x in front of this term. And 2 in front of this one. What does this denominator become? If you take something squared and square it again, it's now to the 4th power. Okay, there is one more thing that I would like for you to do on this one. Does anybody catch one more thing we could do to reduce?
-2 times 5.
You can do that. I'm,
She multiplied the 4 plus 5x plus 6 squared from 1 minus x squared.
you could look at
Divide
both.
out the bottom.
Don't we have the same thing everywhere? So couldn't we reduce one of those? So I'm saying there's one of them here, 2 here. So we could take 1 out of everything. So then we get negative 6x. That was about as nasty as the problem can get on this. We had fractions, we had to do quotient rule, we had to do chain rule for both top and bottom, so that's about as complex as these will get. I know it's frightening to look at, but do you have any questions on how I got there? Let me do one. I'm going to do the next example and then I'm going to stop for today. Okay. Last example for this. I want the derivative of e to the sine x. We know the derivative of e to the x is still e to the x. But my power isn't just x here. So derivative of e to something is still e to the something. So it's still e to the sine x, but when I do chain rule, what's the derivative of the inside? Derivative of sine is cosine x. And there's really nothing you could do to clean that up.
Wait, what?
So my outside function was the e to some power. So derivative of e to a power is still e to that power. Chain rule says you have to do times the derivative of the inside. My inside function is the sine x. So I had to multiply by the derivative of sine, which is cosine.
I thought that